Section 4.3, we continue with the difference of squares. To use the difference of squares, we begin by identifying if the expression contains two squared terms being subtracted. We then find the values for a and b, and we use the following factorization. A squared minus b squared equals a plus b times a minus b. Let's do some examples. Example 8, factor the expression a x squared minus 4. We notice that both terms are squares and they are being subtracted. We can continue with the process of the difference of squares. A squared minus b squared equal a plus b times a minus b. So let's find the values for a and b. Notice that these are the values being squared. I'm going to rewrite the expression such that I have x squared minus, instead of 4, I'm going to write 2 squared. This way it's more visible who's a and who's b. A equals x, b equals 2. Keep in mind that the difference of squares says a squared minus b squared equals a plus b times a minus b. This is the formula we're trying to use. So since we have x squared minus 2 squared, our factored form, it's going to be x squared minus 4 equals x squared minus 2 squared equals x plus 2 times x minus 2. Part B, m squared minus 121. Let's rewrite the expression such that we have m squared minus 11 squared. A equals m, b equals 11. Following the formula a squared minus b squared equals a plus b times a minus b, then m squared minus 121 equals m plus 11 times m minus 11. Part C. Here, if we rewrite the expression, we're going to have t squared minus, and instead of 1, I can write 1 squared. We notice a equals t, b equals 1. So our factored form, t squared minus 1 equals, according to the formula, a plus b. So in our case, t plus 1 times a minus b. So t minus 1. Part D, we have 81 minus y squared. Let's rewrite it. Instead of 81, I can write 9 squared minus, and then I'm going to have y squared. So my a, it's 9, b equals y. The factored form of 81 minus y squared, it's 9 plus y times 9 minus y.